Welcome to Algebra, Solving Proportions. This process of solving proportions brings us one step closer to dealing with real-world problems using the algebra solving techniques we've been doing so far. Let's check it out. As you may recall from your previous math learning, a proportion is simply two ratios that are equal. A ratio is a comparison of two values, often expressed in the form of a fraction. Here is a ratio that could be the comparison of how many boys there are in a group to how many girls, or cups of sugar and flour in a recipe, or the number of lions and tigers in a zoo. To test if two ratios are equal is a simple process. Just cross-multiply and compare the results. If the two values are equal, then the two ratios are equal, and you have a proportion. In this example with the two ratios 2/3 and 4/6, the results of cross-multiplying are 2 times 6, which makes 12, and then 4 times 3, also 12. The resulting equation is correct, thus proving the two ratios are equal. Here is another example. Are these two ratios equal? The cross-multiply test proves they are, with both results equal to 36. Are these two ratios equal? Is this a proportion? No. The results of cross-multiplying result in different values, not an equation, and disproving the proportion. What if you knew three parts of two ratios and wanted to find the missing part, the missing value, to solve the proportion? We simply cross-multiply as we did in the test and make an equation. So 3 times x makes 3x, 5 times 9 makes 45, and then we solve this equation by dividing both sides by 3, x equals 15. This is how to solve a proportion. Very simple. To check the solution, substitute and cross-multiply. We replace x with 15 and cross-multiply to get 45 on both sides, and therefore we check the solution and prove that it is indeed a valid solution. Let's try something a bit more complex. Here is a proportion with a two-part expression containing the missing part, the variable x. We cross-multiply to get 3 times parentheses x plus 1 equals 6 times 4. We use the distributive property to get 3x plus 3 equals, and then 6 times 4 is 24. We proceed to solve the equation by using our processes. Subtract 3 from both sides to get 3x equals 21. Divide both sides by 3, x equals 7. To check the solution, substitute and cross-multiply. X is replaced by 7, so we have 6 over 7 plus 1 equals 3 over 4. 7 plus 1 is 8. And then we cross-multiply. 6 times 4 is 24, 8 times 3 is 24. The solution checks out. Here's another example. We cross-multiply. 4 times 9 is 36. 3 times n plus 4 we distribute to be 3n plus 12. We subtract 12 from both sides. We get 3n equals 24. Divide both sides by 3, n equals 8. To check the solution, substitute and cross-multiply. We substitute 8 in for the variable. 8 plus 4 is 12, and we cross-multiply. 3 times 12 is 36, 4 times 9 is 36. The answer is correct. Here is a proportion with two expressions in one ratio. Again, we cross-multiply, and we get 6 times x plus 2 equals 3 times x plus 7. We distribute on both sides to get 6x plus 12 equals 3x plus 21. Now, we've shown both steps here, subtracting 3x from both sides to gather the variables on one side, and then subtract 12 from both sides to move the value to the other side. And that's okay. And we get 3x equals 9. Divide both sides by 3, x is equal to 3. We replace 3 in place of the variable. 3 plus 2 is 5, 3 plus 7 is 10. We cross-multiply. 5 times 6 is 30, 10 times 3 is 30, and it works.